You are given an integer array containing both positive and negative numbers. Find the contiguous subarray with the largest sum and return its sum. For example, subarray 4, -1, 2, 1, has sum 6, which is the answer here. How do we find the optimal subarray systematically? Greedy alone falls short. We need to consider every position. Let's start with brute force. Brute force. 2 nested loops enumerate every start I and end j, compute the sum, and track the maximum. The outer loop fixes the start, the inner loop extends the end and accumulates. Different starts often share overlapping suffixes in their inner loops. The answer is 6, but time complexity is on 2, unacceptable for large n. The core problem: we repeat a lot of computation. When I equals 0, the inner loop computes num0, num01, num02. When I equals 1, the inner starts at num01, computing num0, num01, 2, num03. Starting from I equals 0 to j equals 6, we already summed nums1, 6. Starting from I equals 1, we sum nums2, 6, again. Each new start rescans a suffix. That's the on2 cost. Key question: can we reuse previously computed results to avoid rescanning? If we cache the max subarray sum ending at I1, we only need one step per element, reducing on2 to on. Define dpi as the maximum sum of a contiguous subarray ending at index I. Ending at I means the subarray must include numz, but can start anywhere from 0 to I. Dup3 equals 4, because the best subarray ending at index 3 is just 4 itself. dp6 equals 6 for 4, -1, 2, 1. The final answer is the maximum among all dpi. At element I, since the subarray must end at numzi, we have exactly 2 choices. Choice 1. Extend. Append numz to the previous best subarray, yielding dpi1 plus numz. Choice 2. Restart. Discard all prior elements. The subarray starts fresh at numz, yielding numz. Take the max. dpi equals max dpi 1 plus numz, numz. Equivalently, restart whenever dpi1 equals 0. A negative prefix can only drag the sum down. Fill the table bottom up. First populate the nums row. Dep0 equals num0 equals -2. Base case, the first element can only choose itself. Dpone equals max dp0 plus numsun. Numzon equals max -11 equals 1. dp0 equals -2 is negative. Restarting wins. Dep2 equals maxone plus -3. -3 equals max -2. -3 equals -2. Extending is still slightly better than restarting. Dup3 equals max -2 plus 4. 4 equals max 24 equals 4. dp2 equals -2 is negative. Discard the prefix and restart from nums3 equals 4. Continue rightward. dp4 equals 3. dp5 equals 5, dp6 equals 6. Each step only needs the previous dp value. Finally, scan dp for the maximum. That's the answer. dp6 equals 6 is the global max, corresponding to subarray 4, -1, 2, 1. Summary: dpi equals max subarray sum ending at I. Recurrence dpi equals max dpi1 plus numz, numz. Base case dp0 equals num0. Answer is max of dp array. On time, 1 space after optimization.